In this session, we want to visit two names or two formulas, two notions when we have measurements, when we have a set of data. So the first one is called coefficient of variation, CV, and the second one is called Z-score. Right. So when we have a set of data, we can ask what is the CV of this set of data. And this set of data, as we can recall, can be a bunch of measurements of the weights of apples, can be a bunch of heights, can be a bunch of incomes, budgets, stock prices, anything that we care to measure. Yeah. So we can ask what's the coefficient of variation of this set of data. Much like we ask what's the standard deviation of this set of data, what's the mean of this set of data. Then for Z-score, it is not about this set of data. It's about one particular piece of data. So what is the Z-score of this 90-gram apple? What's the Z-score of 90? What is the Z-score of this particular student's height? 1.64. So that is how we use this term called Z-score, how we ask this. And then we want to look at the definition. So let's look at coefficient of variation first. Okay. Now there are two versions because CV involves essentially the standard deviation divided by the mean. And because standard deviation has the idea of population standard deviation and sample standard deviation, so we need to ask, wait, which version of CV are you talking about, right? But of course, if our data set is a population to begin with, clearly, all you can ask is going to be CV of this population. It cannot be that I have a population and you say, what's the sample CV of this population? Doesn't make sense. Okay, so it has to be totally aligned or conform to each other. So with a population of data, we ask what's the coefficient of variation? And of course, it has to be sigma over mu. All the Greek letters, remember, they refer to population. And likewise, if we have a set of samples, like the class measurements of 10 students, the heights of them, then we ask what is the coefficient of variation? And of course, you might be tempted to say, but do you mean population or sample, right? But look, if our measurements is about sample, definitely, even if we don't say it, the CV will have to be talking about the sample CV. Now, fortunately, it's a ratio, right? So it's the standard deviation divided by the mean. We will just be using the correct standard deviation, sample standard deviation divided by the sample mean. So notice that even though the idea is the same, use the standard deviation divided by the average, the symbols, when you write down, you need to be kind of particular about it because it will lead to quite a lot of confusion if you're analyzing a sample and you somehow write sigma over x bar. I have no idea what you're talking about. You see that? So a lot of confusion maybe during when you learn your first lesson in statistics and probability is that the either the exercise or the question or even textbook may at times be a bit sloppy or misprint or have a bit of typo here and there, and that can lead to quite a bit of confusion. So here now that you understand this, next time I show you a slide that where I actually wrote the typo and I say CV of sample is sigma over x bar or S over mu, you can then point out, aha, that is a problem, right? Because it all has to be consistent. Yeah, okay. And it all begins with our measurements. Are we treating those measurements as sample? Or are we saying, well, all I care about is just my class of students. My point of analysis is just these 10 students. Then that would be a population, even though it's not a very interesting population. But then the analysis scope is treating it as a population. Okay, so I keep repeating the notion of population and sample because it doesn't have to be that when you have a large set of measurements, then it's called population. Right? If you have a large set of measurements, like 1,000 people whom you telephone and ask them, have you taken your COVID-19 shot? Because you want to telephone and ask and verify, right? For example, even though it's 1,000 households that you call, a lot of hard work and effort out of the whole country's population, that's just a little drop, right? So again, that's just a sample. Anyway, let's come back to our coefficient of variation. What is this? Calculation, very simple. We have learned how to get the standard deviation and the mean, and you just do a ratio will do. So the point of thinking about CV is not about how easy or difficult it is to calculate, but rather why are we having this little ratio here, yeah? And it's an idea more to kind of standardize the standard deviation. Okay, what do you mean by standardizing? Let's look at this example. The airline's annual mileage, let's say the aeroplane flies, each plane flies 50,000 kilometers every year. Sorry, each airplane flies 250,000 kilometers every year on average. So sometimes a bit more, sometimes a bit less, and sometimes a bit longer. All right, maybe 30, 35, 350,000 kilometers, sometimes 100,000 kilometers. So plus minus a bit, and the standard deviation amounts to 50,000, which looks like a lot, right? Looks like a lot. The standard deviation of a stock price fluctuations. Let's say the average is $1. So the stock price fluctuates around 95 cents, $1, $1.05, $1.03, 97 cents. Yeah. So it goes up and down, and the standard deviation ends up being 25 cents. Okay, now we ask which series of numbers, is it the airline mileage or the price fluctuation? Which series of numbers fluctuate more? Which one has a larger fluctuation or relative fluctuation? So to answer this question, if we just look at the standard deviation, of course the airline mileage wins, right? Yeah. So, but that is a little bit of a problem because then it will always win. But is it so? Is it so? So the right way to think about this problem or to answer the question is to standardize it by saying that if your mean is so large, why don't I take on a per kilometer basis? Yeah. So if you divide up, then the units cancel out. Remember, the standard deviation takes on the same unit as the mean value and the original measurement. So kilometer and kilometer cancel out, and CV is a unitless ratio, which is kind of nice because now your stock price also is unitless, which means you can compare. Because look, if you compare SD of mileage with SD of price, it's like kilometers and dollars. It's like apples and orange. How do you compare? No idea what you're talking about, right? But with CV, it's unitless. So mathematically, it's nice. You can really compare. And if you, of course, it may not make much of sense, but if you really want to compare, then you can. It's legit to say that the stock price actually fluctuates more on a per unit mean basis. You see, there's a nice point of reference. On a per unit mean basis, the stock price fluctuates more than the airplane's annual mileage. Right? So that's nice because on a unit scale, the unit is different for a stock price than from a airplane's mileage traveled. Now, you might find this example very why are you taking this comparison? I don't do this all the day, right? All day, right? And you're right. I purposely picked this rather bizarre comparison to give you a sense that you can even do that, right? The more common ways we compare the relative fluctuations is more about different choices across a similar category. So, for example, can we compare the bank stocks fluctuation from the, say, utility stocks fluctuations? Can we compare the property developers fluctuations with, let's say, the oil and gas stocks fluctuations? Yeah, because you are trying to readjust your portfolio, which has higher fluctuations. Maybe you are the risk-seeking sort. You want more fluctuations because you perceive more opportunities for trading, etc. Right? So you want to say, give me those that have high CV. You see, now you need to compare the CVs across different stocks. And still, if you don't convert into CV, you compare with standard deviations, it won't work because there are penny stocks there are also blue chip stocks. Blue chip stocks will be very high and the standard deviations will be very large. Penny stocks might have standard deviations that are a few cents, but that can be 20, 30% of their average trading price, right? So that's very, very risky or scary. So how do we compare? You cannot use standard deviation. And so CV becomes the right thing to do. Let's talk about airline on its own. In the airline industry, you might ask, are we competitive in terms of our control of the fluctuations of mileage travel? Competitive against whom? Your competitors. Your competitors can be regional airlines, can be international airlines, but nowadays it's a bit mix and match, right? Regional airlines go international. International airlines also try to fly regional. And so you might want to compare against everybody. But then regional airlines will fly, on a regional, so it's less. The mean is less, but there can be more fluctuations. The ST can be high or low. We don't know. How do we then compare in a standard way? CV, correct? Coefficient of variation. So that's very nice to compare across all the airline mileages, but across different management, across different regions, across different competitors and companies. So you see, it is nice.